Hi, I'm Clayton Deegan from Malvern Instruments, and we're here today to measure some nanobubbles on our nanoparticle tracking analyzer, the NS300. We have here the setup with a laser module inside, the samples loaded on a syringe pump, and in the software you visualize on screen the Brownian motion of the particles to size them. And in the course of the experiments today, we've seen that distilled water plain has virtually no particles in it. And after treatment in the nanobubble generator, we've seen over 2 orders magnitude increase in the nanoparticle content of the water as measured on the NS300.
So what kind of numbers are we talking about?
We're seeing jumps from 2 million particles per mil to 200 million particles per mil after an hour of treatment on the nanobubbler machine.
That's awesome. So we've gone through the different laser colors and explained the different laser colors related to the energetic effect and on the nanobubbles that you've seen.
So we've brought today 3 different modules here, and each one contains their own laser. So we've got a 488 laser source, a 405 laser source, and a 532 laser source. And we understand that the shortest wavelength is the most energetic, and we found that there's a size dependence and image dependence on the laser wavelength of choice on both count and the total particle size distribution.
And so this is running through it live right now, and this is all being videoed.
Yeah, and this is the track. Now we're under the track, and we've taken 3 30-second captures of the particles moving under Brownian motion, and now you'll see the tracks drop out behind them. All the red tracks are a particle whose size has been validated based on tracking for multiple frames. And we see a size distribution start to develop. And we can put it in the analysis. We get a number count from this.
And at first, we're looking at the energetic response from the nanobubble when you hit it with a laser. And that's characteristic that you see with a particle or a cell or something like that. Right now, we can't make a claim what that response energy possibly is. But when you look at the laser, when you look at some of the particles, they have a very distinct halo around them. And so what was the last color laser that we ran before this one?
We ran a green laser last.
That's interesting because the green laser showed more of the, if we were going to call this a nucleus of the bubble, it showed more of a nucleus of the bubble, and we have video of that for later on, and it showed more like a compass.
Yeah, a little 4-pointed star.
Right.
Surrounded by a halo.
And when you look inside the hydrogen atom, that's what it looks like. Exactly the photos from the electron microscope that NASA has. It looks like that 4-point star where 2 are bright and 2 are dim. Almost identical. And we've raised the hydrogen in this water from 5 pH to 7.7 pH with no hydrogen inoculant, which is very interesting. So there may be a play later on by the different colors of laser. Well, it's pretty good confirmation for today on nanobubbles. Thank you.